So when we talked about the empirical and molecular formula, we used glucose, C6H12O6. And like Brooke just said, we are able to reduce that down, okay, into CH2O, which many sugars that we have, many carbohydrates, sugars, have that CH2O empirical formula. But nonetheless, the empirical formula is a reduced version of the empirical formula. Could something be both an empirical and a molecular formula? Absolutely. It could be both. It could be both. So keep in mind that just because we have something, I believe I've seen one that was C6, very similar to glucose. Okay, I forget where I was since we got interrupted, but I think I was talking about, I saw something the other day that was C6H12O11. Now, could that be reduced? That 11's a toughie, isn't it? That 11 is a toughie, so that cannot be reduced. That would be both an empirical and a molecular formula. Okay? That would be both empirical and molecular. Now, what we're going to do, you work some examples. We're going to work 3 more examples. Okay? We're going to work 3 more examples. So go ahead and copy this one down right here, and then I will work it after you get it copied. Now, for this type of a problem, find the empirical formula of a compound that has a percent composition of 74.17% mercury and 25.83% chlorine. Now, Doc Hirsch was right. Okay, Doc Hirsch was right on how we do this. We are given percentages. So for this type of a problem, when you are given percentages, we are going to assume that each one of those percentages are grams. So I'm going to start off with writing that I have 74.17 grams of mercury. What I need to do in order to compare my 2 percentages, which I'm converting, I'm putting them to grams, I need to convert to moles. So I'm just going to flux capacitor this to moles. So I know that when I have mercury, I know that mercury is 200.59 grams of mercury is 1 mole of mercury. My grams of mercury cancel. I'm going to get my answer in moles. So when I do my math, I take the 74.17 and I divide it by 200.59, and I come up with 0.3697. Okay, I'm going to leave the whole big number. I get 0.3697592103. I'm going to leave that whole number in my calculator. Okay? But I'm just going to round it, or I'm just going to leave it right there. So that's not a rounded value by any means, because I'm not using that value for anything yet. Okay? I could round it. Do you want me to round it just to make you feel better? Okay. So if I would round that just to make Brooke feel better, that would be an 8 there. Okay. So I would hate for a Monday morning her to feel bad because of my lack of rounding. So we'll take care of that. The second one, the same thing. 25.83 grams of chlorine. When I look at my periodic table, I see that chlorine is 35.45 grams of chlorine is 1 mole of chlorine. So I convert this into moles of chlorine. So I take 25.83 and I divide that by 35.45, and it gives me 0.7286 mole. Now, that is nothing new. We've done molar conversions. We've went from mass to moles. Here is the new part. Okay, here is the new part. Which of those values, this is a toughie, which of those values is the smaller one? Good. 0.3698. So what I'm going to do is I'm going to divide both of these by 0.3698. Obviously, when I do that one, I'm going to get a 1, correct? When I come down here and divide my second one by 0.3698, when I do that, I just have to click a couple of buttons. I'm going to get 1.97. Now, for the purposes of empirical and molecular formula, I'm going to consider that 1.97 is very close to 2, right? So, I'm going to consider this a 2 because that 1.97 is very close to 2. So when I come up with my empirical formula for this particular problem is simply going to be Hg, how many of those? 1. Cl, how many chlorines? 2. So what mercury am I dealing with here if I were naming that? If I were naming that, because mercury is multivalent, which one would this be? Mercury 2. So this would be mercury 2 chloride for my empirical formula. I'll give you a second to copy this down. The question states, find the empirical formula of a compound that has a percent composition of 52.94% aluminum and 47.06% chlorine. So once again, when I'm doing this, I'm given percentages. I know that my percentages equal 100. So I'm going to pretend that I have 100 grams of this. And out of that 100 grams, 52.94 grams are aluminum. So I need to, once again, convert this into moles. So I'm going to flux capacitor my aluminum into moles, 26.9815 grams of aluminum is 1 mole of aluminum. My grams do indeed cancel. It's going to leave me with an answer that is in moles. So I take 52.94 and I divide it by 26.9815, and I get my value to be 1.962. Once again, I have a big, long number in my calculator. I'm just cutting it off right there, but I'm leaving that big number in my calculator. So I have my number of moles of aluminum. Chlorine, 47.06 grams of chlorine. I just did chlorine. I believe the number was 35.45 grams of chlorine is 1 mole of chlorine, right? Yep. So 47.06, and from that I'm going to divide 35.45, and I get a value of 1.3275 moles. Now, of those two, which one is the smaller one? Which one's the smaller one of those two? Don't everybody shout it out at once. 1.3275. So I'm going to divide both of them by that value. Okay? And when I do so, obviously down here is 1. And up here is 1.47. Right? We agree with that number right there? Now, when I am looking at this, okay, if I were going to say what is aluminum, what is that closest to? Okay, I'm going to say, well, 1.47 is pretty close to 1.5, isn't it? Okay, pretty close to 1.5. So what I need to do, okay, what I need to do, and usually, folks, usually these values come up pretty even. But obviously, this one did not come up pretty even, did it? Okay, it did not. So what I need to do as I'm going through these is I have this at, let's say, 1.5 because it's going to round pretty close. It's going to be pretty close to 1.5. I can't just say, yeah, that's 2, or yeah, that's 1. Did I do math wrong? What? Go ahead and ask. Okay. When I have 1.5, I can't really make the jump and say 2 or say 1 because it's right in the middle of them. So what I'm going to do is I'm going to make that into a whole number. How am I going to make that into a whole number? That's what I'm going to do. I'm going to multiply that by 2, and if I multiply that by 2, I get what? 3. But what I do to the top one, I also have to do to the bottom one. Okay? So I'm also going to multiply this one by 2. So what is my empirical formula going to be for this one? Al3Cl2. Now, that makes absolutely no sense based on what we know of our charges, does it? Okay? Now, the thing is that I believe, and So now I've changed this since I had the wrong equation. I've changed this to oxygen. We're going to work it now with oxygen being the value. So 47.06 grams of oxygen. If I flux capacitor that, 15.9994 grams of oxygen is 1 mole of oxygen. My grams cancel. I'm going to get moles. So when I divide this new value out, 47.06 divided by 15.9994 is going to give me 2.9413. Sorry, Brooke, I'll round that. I know. I don't want to throw you all off. So, what now is my lowest value? The top one, right? So now my top one's my lowest value, so I'm going to divide by 1.962. That's going to give me 1 there. 1.962. So down at the bottom, it's going to give me that sounds a little bit better. 1.499. All right, so now that value is very close to 1.5. I'm going to multiply it by 2. I'm also going to multiply that by 2. So this is going to give me 3 here. It's going to give me 2 here. So what is my empirical formula going to be? Al2O3. That makes a little bit more sense than that gobbledygoosh that I just had there with chlorine. We okay with that type of a problem using percentages? Okay? Because if I remember right, my third one's not going to have percentages. So go ahead and copy this. My example says a certain sample of a barium salt contains 8.57 grams of barium, 4.43 grams of chlorine. What is its empirical formula? Now, I'm given grams, correct? I'm given grams, so I don't have to assume that this is 100% of anything. Okay, I just take the value of the grams that I have been given. So, I take the 8.57 grams of barium. I need to convert that into moles. Barium on my periodic table is 137.327. My grams cancel. It's going to leave me a value in moles. So I take 8.57 divided by 137.327, and I get 0.0624. 0.624. I bring her down, extend my page a bit. I bring her down, and I have 4.43 grams of chlorine. 35.45 grams of chlorine is 1 mole of chlorine. My grams of chlorine cancel. I'm going to get this value in moles. So I take 4.43 divided by 35.45, and I get 0.125 moles. Now, which one of those values is smaller? Which one of those values is smaller? 0.0624. So I divide both of them by 0.0624. And when I do, that bottom one, my value comes up to be 2.00. So what is my empirical formula for this one going to be? BA is how many? BA is how many? 1. CL is 2. Okay? Now, some things, folks, just to talk about here a little bit. What if I would get a value, and I've seen this, if I come up with a value of 1.33, how am I going to get that into a whole number? I multiply that one by 3, right? If I multiply that by 3, what's that give me? 4? Right? So, I've seen that before, 1.33. Okay? I've seen a 1.75. Okay? A 1.75 is a little bit tougher. Okay? If I multiply that by 2, that's going to give me what? Is that 3.5? That'll give me 3.5. So what if I multiply that by 2 again? Gives me a 7, right? So I would have needed to multiply that by 4. Okay? So those are some of the more common ones that I've seen that you can't round up or round down because it's too far apart. Okay? And believe me when I say that these are going to come out pretty much so. It's going to be pretty close to the number, like the 1.9999 or the 2.000. If you get a really, really screwed up number, you might want to go back and recheck your math again to see if you did something that was not quite kosher. Okay? It was not quite kosher.